International Astronomical Search Collaboration is a group of different organizations across the world, around 30, among which Nepal Astronomical Society, and PanStar is another one. It is situated at the Institute of Astronomy, University of Hawaii in USA, and it is managed by the university, and it creates data that is required for the asteroid search to us. It scans the sky for a real time. It chop up the map, the sky map survey, and sent us in a server which we have to download and analyze. So in those 2 days, we'll be doing that. So more on next section through by other two mentors. Please, next. So what is the all-level asteroid search campaign? Because people are more preferred to use the international word. So all the discoveries we have. So there are different campaigns. So what we hope that after few training and campaign engagement to all of you, probably KIT, the chapter can start KIT Ask for Search campaign, which we really wish to. We have done this for different countries, different universities around the world, and different societies. So we really wish to have do that kickstart at the university as well. And for that, what we do is we have started the All Nepal Astro Search campaign, where we provide hands-on astronomy, opportunity for high school as well as university students and faculties, where we make original discoveries. If you participate in International Astro Search campaign, or if you participate in All Nepal Astro Search campaign, the discovering techniques and data are same. I mean, it's not the same. It doesn't mean that you get the same image set. Every image set loaded in your folder is unique. That means everyone can discover asteroid. It is not a mock test, though today and tomorrow we'll do this practice in a practice set, not the real set. But we can also work afterwards in a real set to discover real time. So what we can do immediately, we can put you in the upcoming campaign, All Nepal Asteroid Search campaign, so that you can do practice what you have learned in those 2 days to discover asteroids in real time. And we keep it free. We have a training sessions like this in a collaboration. We also provide paid training tips, training programs to generate revenue for the society, but most of the programs are usually free because our idea is to empower society as possible, to inspire more people to do STEAM, more people to go for innovations. Like Prajwal has joined our program long time back. This program he joined, then again he joined the International Asteroid Search campaign later on. So once you are trained, you can join any asteroid search campaign programs as long as they register your team. And we are very welcoming registering team from international as well, and we have a capacity to increase our team limit as well if we know in advance. So we can have 300 teams once, we can have 500 teams who want to work, even 5 teams, 10 teams. If by default we have 15 to 30 teams every month. So every year around the year, almost every month we have a campaign. The campaign is like a 4 weeks one, and we do discover that, and it's not real time. So what you have to do is you can search at your convenience from home once you know the technique. So what we encourage, you should work in a team, you should collaborate with each other, and once you develop the skills, then you can divide the work, the task, and start working so that you can finish the task in time. So because what I said earlier is every image set may have asteroids to be discovered, waiting for you. So yes, that's what we created in Nepal in 2016. Before that, we were doing this in an ADAC one, in participating in International Asteroid Search campaign through the partnership. Then we started on a dedicated one where we can have our style of teaching, our style of training, and provide more mentorship. Because in ISAC campaign, there will be other people training, so you may not have the dedicated support available, which we provide through our All Nepal Asteroid Search campaign. And we expect those trained students can join any campaign. Like we first expect to join NSC, but we also encourage them to join any campaigns available. Because we have discovered 60 plus. The number is increasing, more than 1500 plus preliminary. It's increasing month by month. So I hope we'll add more with you all next. Thank you from my side. Now over to you, Dipti.
Hello again. It's me, Dipti Gautam, manager at Nepal Asteroid Research Program, Nepal Astronomical Society. So let's go through and around the asteroid. Why do we search them? First of all, connecting with the curiosity to discover and commitment to discover, dedications and sense of responsibility to protect the planet. So we may think, how does this protect our planet? You may know that you may listen the rumor. So, you may have listened the rumor that asteroid is hitting the Earth. So what do you how do you think that people know about the asteroid approaching the Earth? So the discovered asteroids can be tracked and regularly, and their changing behavior path by different value. And how do we search them? For searching the asteroid, we use one software called Astrometrica, carefully observing the moving object in 3 to 4 image set provided by the ISC websites and Minor Planet Center. We analyze them and submit the reports and search the asteroids in different bases. And how do we source them? So we source them in the collaboration of IASC and All Nepal Asteroid Source Campaign, is earlier said by Mr. Suresh Patrai, chairperson of Nepal Astronomical Society. We have 1500 plus preliminary discoveries up to now and 60 plus provisional discovery and number of participants. Not only this, we have a lot of participants reach us up to now, just like Nepal, India, Pakistan, UAE, Brunei, Bhutan, Bangladesh, and Sri Lanka, and so on. So heading toward to Ankita. Thank you.
So hi again. I'll be going through the Astrometrica software. So next slide, please. Yeah. So what is Astrometrica? Astrometrica is an interactive software. It is mainly designed for processing the CCD images, particularly useful for finding, tracking, or reporting the moving celestial objects such as comets or asteroids. We'll be using this software for discovering the asteroids. So the current version for the of Astrometrica is it is the successor of POS based software. So the credit for Astrometrica goes to Herbert Rabb, who was born in 1969. Before Astrometrica, they used photographic films for measuring the position of minor planets and finding the asteroids. But after the discovery of CCD, they switched into CCD, and Astrometrica software has been used since 1993 to till now. So next slide. So and also Astrometrica software does not work on Mac and Linux systems. So you must have a Windows system for uh, that for using Astrometrica. So what are its features? So Astrometrica reads FITS, which stands for Flexible Image Transport System. It is a standard data format used in astrometry and SVIP files. And it has automatic image calibration, linking with automatic image alignment. Okay, if these all these things sound fancy to you, then no need to worry. We will all get through this while using the software. You will be familiar with the software. And also I have already sent the link for downloading the software and the practice set. So continue downloading that software also. Other features are you can track and stack the images, and you can access the complete MPC database. So MPC stands for Minor Planet Center. So it is responsible for the identification, designation, and orbit computation of all those objects, for example, minor planets or asteroids, comets, or other irregular natural satellites of other major planets. So it's a single worldwide location for receipt and distribution of positional measurements. So you will have the access to complete database and access to new generation of star catalogs. Star catalogs it's Suresh sir already told about the catalog. So, for example, this Atlas REFCAT, this star catalog has more than 1 billion stars down to magnitude 19. So, if you don't understand what does magnitude 19 mean, so no need to worry, you will not need that now, but we will need that while using the software. So, you will know it while using the software, and it includes internet access, which provides the access to database and query reference star catalogs for Visor. So what are these star reference stars? You will know this also while using the software. So next slide, please. So how does the interface look? Um, you may not be that happy to look into this interface because these are the CCD images. Uh, like when someone asks you discovering asteroid, you may think of some stone orbiting around, and you will work on that. But no, you will work on the images, and the images looks like this signal which we used to see in TV when channel goes out. So these are the images that we will be working on. So here in this particular image, here is a red circle, which is a minor planet detected by the software, and on the background you can see green circles. So those green circles means the good reference stars, and I don't see any bad reference star, but there will be yellow circles which represents the bad reference stars. So there is one dialog box open for the verification of the object. It's seen at the center. So the coordinates will be in right ascension and declination. There is written by R A and D E, and the G means magnitude. So the magnitude and the coordinates of the particular object that you are working with will be shown in this display, and there are two graphs um, and some additional data which we need to visualize, and then we will work on those data. If those data meet the criteria, then they are eligible for, they can be asteroids, and if they don't fall into the criteria, we will reject them. So these are the things we'll work on in hands out session. So next slide, please. So the things to remember, first of all, you have to download the Astrometrica software. It does not work on Mac and Linux system, so you must have a Windows system, and download the Astrometrica from the link that I just provided on the chat box. So, and also don't forget to download the practice set from the same website. And after downloading, we have to calibrate the software. So what does it mean to calibrate? Is already told by Suresh sir that we are using Pan-STARRS telescope, so there are configurations that we need to calibrate before working on the images. We'll do that, and then we have this ROSE criteria, which um, this ROSE criteria basically defines if we can accept an asteroid or not. It is mainly based on the SNR values, the signal to noise ratio. We will talk about that later. So yes, so introduction to mentors. We already did the introduction part. So here's Suresh Patrai. We have Suresh Patrai, chairperson of Nepal Astronomical Society, and we have Miss Dipti Gautam, manager Asteroid Search Program, Nepal Astronomical Society, and me, Ankita Patrai, manager Space Outreach Program, Nepal Astronomical Society. So if you have any questions, we are happy to answer. Okay, if there are no questions, then this was our short introduction, a brief introduction of the software, why we do asteroid search, how we do asteroid search. So after this, we'll be working hands-on. So first of all, please download the software, and over to you, Suresh sir.
Thank you, Ankita and Dipti, for this wonderful presentation. I hope it provided a clear overview on what we are going to do today for an hour or so and tomorrow, because it needs time. So we slowly speed up So before that, before we move on to the breakout rooms, we will be having three breakout rooms so that we can interact with each other rather than interacting here. We'll splitting the size in the groups in smaller sizes. So I'll be taking care of one room. Dipti and Ankita will be taking care of another two rooms. So before going to the breakout room, if you have any queries so far what we have presented or anything that is coming to your mind about this program, or why we do this, or why you want to discover more, or what are the requirements, then please feel free to ask. As Dipti and Ankita has already shared that this software, the specific software will be using, does not work in Linux system and this Mac OS system. So it only works in Windows. Luckily, when I started, it was 32 bits. Now it also works in 64 bits system. In Windows, it only works in Windows, not other systems. So please make sure on that. You may want to try whether it works or not with different, creating different ways. But I would suggest not to spend time on that because you will be losing your time based on experience what people have done in our previous workshops. So if you have access to Windows computer or laptop at the moment, that's perfect. All you need is computer that is equipped with Windows system and good internet connections and your vigilant eyes. Then the rest we will take care of. We'll take you through the discovery pattern. So if there are any questions, you can post on chat. I can answer, or you can unmute yourself, raise your hand, and unmute yourself, unmute, and then we can proceed further. Yeah, aren't there automated system to do this? If we are detecting a moving streak on an image, no. I mean, that's the whole point. We need human intervention to discover asteroids. So actually, what we are discovering is not an asteroid. What we are looking at is a moving object. Okay, so we are doing the moving object detection, and possibly if it matches the criteria that we said, so we report them to check to the official unit of IAU, which is Minor Planet Center, hosted by Harvard University, and it is the server is there. It is managed by Institute of it is Astrophysics in Harvard University, and they will check and they will verify. So that's the official body. So how it works? We first detect, we suspect, we give a name in a 7 character style, alphanumeric. We report to our partner, ISAC, and ISAC report to MPC. So we don't report directly to MPC, okay? Because it goes to Minor Planet Center that has the codes. Like, for example, if we buy a car, it has a number. The Minor Planet Center's members, the telescopes, has numbers. So we'll be using this F51 and 52. I think the number code of the telescopes, two of the telescopes in Pan-STAR, and we report to Pan-STAR people, and Pan-STAR people will report. We actually report to IJAC. IJAC report to Pan-STAR. Pan-STAR report to Minor Planet, and Minor Planet again get back to the Pan-STAR. Pan-STAR to ISAC, and ISAC to us. So it goes that way. The communication channel is like that. So it is not possible. That's why we need human intervention. So we did it like, for example, you will see when we work on the data, you will see why it is not possible. The machine can not only do it. Of course we can improve, because most of you might be very good at doing machine learning and data mining. We can improve that, but for now we need human intervention to discover asteroids. And let me tell you one thing, it may be interesting to you. So far there are like we have marked, we means the scientific community have marked all the asteroids which are like about kilometer or even 500. So our goal is to the way the campaign is basically promoted throughout the world is to hunt asteroid of size about 300 meter or less, 150 to 300 smaller size asteroid, because all the bigger size asteroids have been already named, already marked. Because once we know the asteroids, we know their character, then we know how to deal with them, right? So it's kind of you're guarding an area, giving sentry, like a army man. and reporting to your line command about something suspicious. So we are doing that through those images, dark and black and white. And if the reporting line, the officer will tell us, the official officer will tell us whether that's asteroid or not. And if we give them good hints, the credit comes to us. So they will do all the tasks. This is a basic one. But once we have our asteroid, we can do more study on it. Like we can study its orbital physical parameters. We can do a lot. So we are planning to have detailed paperwork once we hit the 100 provisional. We probably can hit that by next year, by the first half of the next year. Because once we name it, it will take about a year to get whether it will be named as provisional or not. We will get the information whether it goes to preliminary or not, because not every marking report will get a preliminary status. But once the preliminary status is received, so it will take another 7 to 8 days. All the telescope around the world will look at that object, and they will reconfirm whether it's asteroid or not, trans-Neptunian objects, TNO. So we get credits from here, the asteroids as a minor planet center, objects, and also the trans-Neptunian objects. So for asteroids, there are mainly main-belt asteroids, which is regular. But our interest is some dangerous, potentially hazardous asteroids. It's quite interesting because while searching them, finding them is quite interesting because we want to protect our planet Earth. Because so far this is the only place where we can live. So how do we protect from our contribution is the way that we are doing tonight and tomorrow and furthermore. Okay, if there are any further queries, please feel free to ask. I hope I managed to answer. What's the advantage of detecting the small asteroids, considering a large one which typically pose? And now we know those larger asteroids, which can be there are techniques like, since I'm involved with the space industry for quite a long time, more than a decade, there have been, like, we don't have that resources here at the moment, but even in India you have spent quite a lot to build different technologies. In Europe and USA and West, they have developed some technologies. French are still, some of my friends, they're working with big companies and they're working on that. The small asteroid is potential dangerous, because a larger one, we know their behavior, but smaller, we don't know how many out there and how hazardous they are. So it's very important. It's kind of to identify them as soon as possible, as fast as possible, so that we can track them. And if we require, we blow them out or we deviate them if they enter our atmosphere. If they are okay going around on their own doing their business, if the asteroids are doing their own business, not bothering to us on planet Earth, it's fine. But if they try to enter, then we have to be ready. So if we don't know our enemies, like the asteroids, if coming to Earth, then how do we deal with them? So that's why those smaller asteroids are not known. Many of them, hundreds of them, thousands of them are still unknown. We don't know the path. So first idea is to identify them so that we can prepare ourselves to protect them. This is like planetary. The program is especially handled by planetary defense system by state, USA, the NASA one. So ultimately, there are different organizations, doing this. They are putting different stuff, the tracking system, but our input goes at the first place. So that's why we get the credit. Okay. Any other further queries?
Yes, sir. Sir,
Yes.
actually, I wanted to ask, how do we know, like during the campaign, that whether an asteroid has already been discovered or not?
Okay. That's if it's already this. We'll do that during practice sessions as well. I think we should move in a couple of minutes to the room. If the asteroid is already named, it will show the name, given name there. If something matches all the criteria, but there is no name in the designated area, that means it is a good chance for us to name it. Okay, so we are not supposed to rename it if the name shows up. Like for example, you saw something and it says k like 2020 age at 25, then you should not rename it. You should not rename it and give name. So the name will be visible in the software. So if it does so, we simply need to accept it. So all we'll be doing it, we are loading the image set, we are putting them in a motion, we are looking at the moving object, we are following the criteria set, and accepting or rejecting that object detected by the software. And sometimes the software may not be able to decide correctly, so we need to use our practice. So the more we practice, the more we know what can be the possible asteroids. So for example, the Roach criterion we'll be discussing says that 5 or greater than 5, but sometimes looking at the object using a mind, we may require to accept the Roach criteria, like SNR value 3.5 as well, if it matches other criteria. There are 3 4 criteria we'll be discussing during the breakout session. Like for example, we'll be looking at the magnitude, which should be fairly constant, because all of you are here, so I would like to say that so that you can. The one, we will be looking at the SNR value. Okay, that is signal to noise ratio value. As per the Roche criteria, it should be 5 or greater than 5 in all 4 or 3 images. Like if we load, it's kind of taking pictures of this in an hour, so every 15 minutes. And if I stack them together, if I move, then you'll be able to detect my motions, right? And the motion should be unidirectional. So I should, if I'm an asteroid, I should move like this. So I cannot do like zigzag, so I cannot do to and fro. So it should be in unidirectional. It should be fairly round, how the mentors will tell you during the breakout rooms. And it should have fairly constant magnitude. There are like R value, G value,